Yeah, hello. Today we're going to look at the direction of a vector. How to find the direction or the bearing of a vector. And we'll take the example from the West African Secondary School Certificate Examination, the November paper, that is the private candidate, and from the year 2013, objective question number 38. The question reads, which of the following bearings gives the direction of 2i minus 2j? So we have a vector here, 2i minus 2j, and we have to find the direction or the bearing of the vector. A says 045 degrees, that is 45 degrees, and B says 090 degrees, that is 90 degrees, C 120 degrees, and D is 135 degrees. So which of these four options is the correct answer? Okay. The calculator has a mode for solving questions under vectors, that is the number 8, but we want to use the number 8 to solve this question. To find the bearing of a vector, the calculator has no option that gives that, so we will use another mode which is called the complex mode. The complex mode is used for complex numbers, but we will borrow it to solve questions under vectors. So let's start. If today is your first time here, don't forget to subscribe and hit the bell for more videos. So we're going to find the direction or the bearing of the vector 2i minus 2j. So the vector is 2i minus 2j. To find the direction of the vector, we need to sketch the vector on a Cartesian plane. So we will do something like this. And we have that. No, that's not nice. Let me try it again. We have something like this. Okay, so we have the 2i, that is the 2 on the x-axis. We have 2 here. Then we have negative 2 on the y-axis, so that will also be here. Negative 2 on the y-axis. So the 2 points meet here. The 2 points meet here. And draw a line, a straight line to the points. Okay, we want to find the angle here. That is bearing. The bearing of a vector is measured from the geographic north in a clockwise direction. So that is the north. That is the geographic north. So we have to measure the angle from the north till it cuts this line. All right, so that is what we're going to do. Okay, so let us connect these 2 points also with the line. Now from this point, that is the origin to this point, is 2 units. Of course we see 2 here, so here is the whole of here is 2 units. Then from this point to the origin to this point is also 2 units. So we have 2 here. So with respect to this angle over here, that is theta, this side is the adjacent and this side is the opposite, because theta is of course facing this side. So, and the length of this side is also 2. So that means we can write the tan of the angle theta will be equal to 2 out of 2. When finding the angle, we don't use the negative sign. That is, we don't employ the negative sign. The negative sign is to help us know which quadrants the angle lies. So now we have tan theta equals 2 over 2, and 2 into 2, 1, and 2 here, 1. So tan theta will be equal to 1. And to find theta, we need to take the tan inverse of 1. So theta will be equal to tan inverse of 1. And the tan inverse of 1 is 45. so theta is 45. So now the angle that we want is the angle from the north to this line, and from the north to the x-axis is 90 degrees, then plus the angle theta. So the angle we want, angle will be equal to 90 degrees plus the theta, and that is equal to 90 degrees plus 45, and that gives 135 degrees. So that is the correct answer we are looking for. All right, back to the calculator. So that is the solution, and step 1, what we will do here is to press mode. So press mode, and when you press mode, you see this as the screen display on your calculator, and in your book you see this. You see complex, start, base n, and so on. Okay, so let's go on to step 2. Step 2, press 2 to select CMPLX. So I'll press 2 to select the CMPLX. Now the moment you press 2 to select the complex, make sure that you have CMPLX on top of the calculator, that is on the screen. So you see it over here. And let's read something small here. CMPLX will show on the top of the calculator. Of course it will. This allows the students to type complex numbers. This mode can also be borrowed to perform operations on 2x1 vectors. Of course, the vector we are dealing with is a 2x1 vector, that is 2i minus 2j. So we can also use the complex mode to solve questions involving 2x1 vectors. You know, this is an innovative technique that we can use. The student is warned not to confuse complex numbers with vectors. This mode is meant for complex numbers, yet we are using it to solve questions under vectors because we can. Step 3, press 2. So you press 2, we have 2i, so then you press on the engineering button, that is ENG, and it is here. There is an I on top of the ENG. It is a violet color, so you press on ENG, then you see 2i. So what we're doing here is that we are typing the vector 2i minus 2j here. So the 2i means 2 on the x-axis, and minus 2j means negative 2 on the y-axis. But we don't have the j on the calculator. Of course, that is not a mode that we use for vectors. This is not meant for vectors, it's meant for complex numbers. We are just using it to solve questions on vectors. So you press minus 2. So what the students must know or note is that the number without any letter is the j, that is the number on the y-axis. So the 2i is on the x-axis or on the i-axis. The i-axis is the same as the x-axis, and the j-axis is the same as the y-axis. So the negative 2 is on the j, or on the y-axis over here. We don't have j here because this mode is not meant for vectors. All right, so this will be the screen display. Of course, this is what we will see here. So when we look at the calculator, we see 2i minus 2 on it, and you must note that there is 2i minus 2j. All right, let's go on to the step 4. Step 4, what should we do? We should now press shifts and press on the complex key. So we press shift 2, and we have CMPLX on top of the 2. So I'll press shift. The moment you press shift, make sure that you have the S at the extreme left corner of the calculator. Then you press on the number 2, which bears the CMPLX. Okay, so when you do that, that is what you see. You see 1 is argument, that is ARG, and you see 2 is conjugate, that is conjugate over here, and 3 we have R, then we have the angle sign, and theta. R is the magnitude of the vector, and that is the angle or the direction of the vector. So A plus BI is also the coordinate form, or should I say the Cartesian form of the vector That is, if you want to change it back from the magnitude and bearing form to the component form, so that you have it this way. So that is the magnitude. The number 3, that is the r theta, is the magnitude and direction form of the vector, and that is the component form of the vector. All right, so that is what you see over here. That is screen display. We see this over here. Step 5, press 3 to select the magnitude and direction. So I press 3, then I see this. That is 2i minus 2 will be converted to, that is the vector in component form will be converted to the magnitude and bearing form. So that is the screen display. I have it here, and I'll now press on the equal sign, and I'll see this. So I'll see 2 root 2, then I'll see the sign, that is the angle sign, and I'll see 135. So 2 root 2 is the magnitude of the vector, and then 135 is the direction of the vector. That is 135. So that is the screen display, and that's what is over here. This means the magnitude is 2 root 2, the direction or bearing is 135. So the answer is D, that is 135, and this is the correct option. I want us to look at an alternative approach here. So let us reset our calculator. Shift 9, you press on 3, equal sign in AC. Alright, so first we will press on mode, then still we will choose the 2, that is the complex, and we will type vector here, 2i minus 2. So here we will not type shift 2, we will rather press on the equal sign to give us the vector in component form. What you have to understand here is that this vector is negative 2j plus 2i. I have said that this mode is not used for vectors, it's not a mode for vectors, but we are just employing it to solve this question. So you should understand that the 2i is the 2x here, that is the 2 on the x-axis, and now we want to find just the angle. There is no need to find the magnitude, so you first press on the equal sign and get this, then we go to shift 2, then here we will not use the 3 because we don't want the magnitude, we don't want the magnitude and the direction. We want only the direction of the angle, so we use the arg, and that means argument, and that is the angle, so 1. So we are finding arguments of 2 minus 2i, and that is what argument of the answer. So you can press on answer first, or you can just press on the equal sign.